We know about exponential functions. Let us now explore about logarithmic functions. For real numbers b greater than 1, if b raised to the power x is equal to a, then logarithm of a to the base b is x. For example, 3 raised to the power 4 equals 81 can be written in terms of logarithms as log of 81 to base 3 equals 4. Similarly, 10 raised to the power 3 equals 1000 is equivalent to saying log of 1000 to base 10 equals 3. We can say that logarithmic functions are the functions defined from the set of positive real numbers to the set of all real numbers. It maps a number x to the real number y if b raised to the power y is equal to x. Same as the case for exponential function. If base is 10, we say it common logarithms, and if base equals e, then we say it natural logarithms. Often, natural logarithm is denoted by L, n, but here we will denote natural logarithm by log of x, that is, L n of x will be written as simply log of x. Here, the plotted graph shows the logarithm function to base 2, e and 10. The log function is ever increasing. That is, as we move from left to right, the graph rises above. The point 1, 0 is always on the graph of the log function. For x very near to 0, the graph of log x in the fourth quadrant approaches y-axis but never meets it. Observe the graphs of log of x and e raised to the power x. The two curves are the mirror images of each other reflected in the line y equals x. Some logarithmic rules. There is a standard change of base rule to obtain log p base a in terms of log p base b. We consider the alpha, beta and gamma as given here. This gives us equations 1, 2 and 3. From equations 1 and 3, we get b raised to the power gamma alpha equals p. Now, from equation 2, we get b raised to the power beta equals b raised to the power gamma alpha. So, beta equals gamma alpha, which gives log of p base e equals log of p base b upon log of a base b. Let us understand it with few examples to get a feel for this. We know 3 raised to the power 4 equals 81. In terms of logarithms, we may rewrite this as log of 81 to base 3 equals 4. Similarly, 10 raised to the power 3 equals 1000 is equivalent to saying log of 1000 to base 10 equals 3 and so on. Thus, logarithm function can also be defined as a function from positive real numbers to all real numbers defined by as shown. Same as the case for exponential function. If base is 10, we call it common logarithm, and if base equals e, then we call it natural logarithm. Here is a quick recap of the learnt concepts.